Air pollution. When a substance with toxic or harmful effects is released into the air, the result is called air pollution. Air pollution can occur inside a building or outside. The diagram below illustrates examples of air pollution caused by various emissions. Common sources of air pollution related to agriculture include emissions from motor vehicles or similarly powered appliances, factories and other industrial facilities, agrochemicals, forest fires, and livestock manure and emissions, or methane. Air quality. Air pollution impacts air quality, a measurement of the quality of air near ground level. Air quality is important because it is the air that humans and livestock breathe. Plants are impacted by air quality in cellular respiration. Photosynthesis can improve air quality on a small scale. Air quality is measured using the Air Quality Index, which measures air quality on a scale of 0 to 500. The lower the AQI score, the better the quality of air. The next slide shows a table of AQI and actions to be taken depending on the AQI score. This slide shows the Air Quality Index table from 0 to 500. Air quality is measured on an ongoing basis by monitoring the average amount of harmful pollutants in the air. The quality of the air changes from day to day based on several factors including natural disasters like fires or volcanic eruptions, wind patterns, local temperature. Hot temperatures combine with sunlight to intensify the presence of ozone near the surface of the Earth. Prolonged exposure to poor air quality can cause an increase in the likelihood of developing asthma and other chronic lung conditions. In addition, individuals with chronic health problems are also more susceptible to acute health issues during poor air quality days. How might air quality impact agriculture? Discuss. Air quality in agriculture. The quality of the air impacts the ability of humans and livestock to breathe well and fully. Air that has more of any one pollutant than carbon dioxide will challenge plant photosynthesis and growth. The diagram on the right can refresh your memory about the photosynthetic process. Air quality standard. There are 5 key pollutants which are measured to define air quality: sulfur dioxide, carbon monoxide, nitrogen oxides, ground level ozone, and particulate matter. For each of these pollutants, there are standards to determine if they are at a safe level for the air to be breathed for people. Particulate matter. The term particulate matter refers to small solid or liquid particles that remain suspended in the air. Some particulate matter is large and can be seen suspended in the air. These include particles like sand, dust, soot, and smoke. Other particles that remain suspended in the air are very small and cannot be seen. Many of these very small particulates include pollutants from commercial industries, automobiles, and other fossil fuel burning engines. Particulate matter can impact solar radiation by blocking the sun's rays from crops. Burning plant matter, some fertilizers and agrochemicals, and older vehicles can all contribute to particulate matter. Particulate matter contains small particles of varying size and effect. The greatest risk is from particles less than 10 micrometers in diameter, called PM10. These can go deep into the lungs and can lead to premature death in people with heart or lung disease, non-fatal heart attacks, irregular heartbeat, aggravated asthma, decreased lung function, and increased respiratory symptoms such as irritation of the airways, coughing, or difficulty breathing. There are not considered to be any safe levels of PM 2.5. The levels of PM are often reported alongside the Air Quality Index. On a clear day, the amount in the air can be below 5 micrograms per cubic meter. The 24-hour concentration of PM 2.5 is considered unhealthy when it rises above 35.4 micrograms per cubic meter. The potential damage depends not just on the concentration, but also on the duration of exposure. The longer you are exposed to PM 2.5, the higher the risk of developing adverse effects caused by the exposure. Even smaller particles, less than 2.5 micrometers in diameter, called PM 2.5, can be a major cause of haze and environmental damage as they travel over great distances. Their environmental impact includes making lakes and streams acidic, changing the nutrient balance in coastal waters and large river basins, depleting the nutrients in soil, damaging sensitive forests and farm crops, affecting the diversity of ecosystems, and contributing to acid rain effects. The American Heart Association states that exposure to PM 2.5 over a few hours to weeks can trigger cardiovascular disease-related mortality and non-fatal events. Longer-term exposure increases the risk for cardiovascular mortality to an even greater extent than exposures over a few days and reduces life expectancy within more highly exposed segments of the population by several months to a few years. Ozone. Ozone is a colorless gas which, while essential in the stratosphere, is dangerous to breathe. According to the U.S. Environmental Protection Agency, ozone can cause a number of health problems, including coughing, breathing difficulty, and lung damage. Exposure to ozone can make the lungs more susceptible to infection, aggravate lung diseases, increase the frequency of asthma attacks, and increase the risk of early death from heart or lung disease. When ozone levels are high, strenuous outdoor activities should be avoided to avoid excessive exposure. Plants and livestock should also be protected when ozone levels are high. Carbon monoxide. Carbon monoxide is an odorless, colorless gas that can build up in your bloodstream. It binds to hemoglobin, making the hemoglobin incapable of carrying oxygen to your cells. Carbon monoxide is caused by burning hydrocarbons with insufficient oxygen present. Excessive CO can lead to injury or death. Improperly ventilated appliances, engines, or generators in an enclosed space can lead to CO poisoning. CO can also build up to an unacceptable level in outside air due to too much traffic because CO is emitted by gasoline engines. Clean air has CO levels of about 100 parts per billion. That means that 100 out of every billion air molecules is a CO molecule. Levels of up to 9 parts per million are not considered a risk. Levels above that are considered a health risk. Sulfur dioxide. Sulfur dioxide, or SO2, is a colorless gas with a strong odor. It is generated by burning coal or oil at power plants or when smelting copper. It irritates the skin and mucous membranes of the eyes, nose, throat, and lungs. At high levels, it can affect breathing, worsen asthma attacks, and worsen existing heart disease. It becomes increasingly dangerous at levels above 2 parts per million, meaning there are 2 sulfur dioxide molecules per million particles of air. Air pollution in agriculture. Agriculture impacts air pollution through the release of ammonia and other chemicals via agrochemicals and livestock waste, vehicle emissions, particulate matter generated from cultivation and emissions. Agriculture produces greater pollution when it is upwind or upstream.